from Stellar, and I would like to invite everyone again, grab a seat. It's going to be another exciting workshop, so please stay tuned. And here I'll pass the mic to our presenter.
Hi everyone, how are y'all doing? Do we have some energy? Are we all full and whatnot, I presume? I'm pretty stuffed myself. Those raps were pretty good. All right, hi everyone. My name is Anuhya. I'm from the Stellar Development Foundation. I work as a developer advocate specifically focused on our ecosystem partnerships, grant funding, so on and so forth. Stellar is where blockchain meets the real world. That is our motto. That is what we stand for. Next slide there. So currently a big problem, as we all know, the big reason why we are in this space is because we want to convert cash to digital assets in a borderless economy. And so this is a big problem, and Stellar helps solve that. And we have done it since about 2015, or 2014, 2015. We have been doing it. Our mission is to create equitable access to the global financial system. So that is what Stellar has been doing for quite some time now. Next slide. So a bit about Stellar. We are decentralized, we are fast, scalable, and a uniquely sustainable blockchain. What is the Stellar Development Foundation? We are a nonprofit organization that is focused on working with and supporting the change makers to create equitable access to that global financial system. So the foundation's main goal is to support and help developers grow and achieve this mission. How do we do that? Well, quick network stats here. We've done about 13.5 billion in total operations, 5.9 billion in total transactions, 7.7 million total accounts, and all of this with less than an hour downtime, which is pretty impressive in the blockchain space, I think. So we are actually a proof of agreement. We are not any of the common proofs. We are the Stellar Consensus Protocol. Validators are run by known entities, and all validators specify sets of other validators that must agree with one another, so quorum slices, and for redundancy, validators accept multiple quorum slices. Recently, we just had a protocol upgrade for our Soroban, which is our smart contract platform that has launched on mainnet. So we just went through a consensus protocol upgrade that had the Stellar Consensus Protocol there. The benefits of this are open membership, issuer enforced finality, and no capital required. And lastly, I want to do a little spiel about our grant funding program. The Stellar Community Fund is a great place for any of you builders looking to kickstart your projects off the ground. If you're interested in the payment sector, the DeFi space and whatnot, the Stellar Community Fund is the perfect place to kickstart your projects because we have we have $100 million Soroban adoption fund, of which we have $50,000 for an activation award and up to $100K in grant funding through our community award process. So I'm happy to talk to more of you about that as well. So this is for developers, startups, full-fledged companies building on Stellar. So we as a foundation are really here to support any projects that are building very seriously with that goal in mind of creating that equitable access to the global financial system. Thank you all. So I just wanted to give a little spiel there before I hand it off to Julian to talk about the DeFi capabilities on Stellar.
Thank you, Leah. Thank you. Hey everyone, how's it going? My name is Julian Martinez, Senior Developer Advocate here at SDF, and we're talking about a super exciting topic, and that is none other than DeFi on Stellar. I forgot to mention that I am a fellow builder and also a common man, so shout out to all my fellow builders out there. Here's a quick overview of what we'll be covering in our show today, or my presentation. So yeah, let's just get it kicked off. First things first, what is DeFi? We could think of DeFi as a broad category of financial applications built on blockchain that aim to bypass centralized entities. So a couple of key points here on DeFi is anyone with an internet connection can participate. We have custom financial instruments including lending and borrowing, asset trading, yield farming, and more. And if we take a look at the centralized transaction versus decentralized transaction image here, you can see that if someone wants to send funds to another person, first, their funds are taken full custody of by a centralized entity such as a bank. Now, as Americans in the state, this might seem like very trivial, right? But we do see some people in the world that are underbanked and do not have access to financial capabilities such as us. For example, we had a team hold an event in Africa, and just to get funds from the United States over to them, they had to jump through a bunch of hoops and ultimately got some funds like shaved off the top just because of the nature of the way funds are transferred from the States to other places. Now, if this had been a decentralized transaction, the only thing they would have had to rely on is the blockchain and the nodes that support it, right? So the only thing that could stop a payment from going through from one country to another if it was a decentralized transaction is if the chain failed itself. And the probability of that is highly unlikely, making it more secure, in my opinion, than centralized transactions. So let's go through a brief history of DeFi to up to not where we are now, but some key events. First, we have, in 2015, we have Ethereum hitting the scene with smart contract capabilities, which ultimately leads to early DeFi such as MakerDAO, Aave, and DAI. Next up, in 2018, we have a boom of decentralized exchanges and automatic market makers such as SushiSwap, Uniswap, etc. And then 2020, reward farming really takes off. And then in 2021, we have NFTs that hit the market to really scale DeFi, and we also have other layer 2 solutions that further scale DeFi. And here's another quick timeline of TVL that we locked in from 2019 to April 2023. As you can see, we peaked here in November of 2021 with around $250 billion total value locked across chains, according to Statista. We kind of took a tank here, a dip here, and we tanked to 48.65 billion. And again, this data is up to 2023, so feel free to check the stats now. So this is just a brief glimpse of where we are, and you know, where we aim to go may be a little hard to measure, but some might say, or another way to look at it would be to take a look at the assets under management in the traditional finance sector. So if we're at 48 billion now, then we could potentially try to reach 122 trillion. So as you can see, we're still in the very, very early stages of DeFi, and we have a lot of work to do to reach this number. So let's go ahead and dive into the diverse world of DeFi. We'll go over a couple of products that exist in the space here. We have stable coins. Some of these are pegged to an asset such as USD, and it can be proven through like a protocol such as proof of reserves. There's also algorithmic stablecoins, which buy and sell cryptocurrencies to kind of like adjust the price of their token and make sure that it stays at a stable price. And these could be really seen as like the building blocks of DeFi. They help you avoid volatile assets and kind of secure your funds, allowing you to kind of stay above the rough waters of volatility in DeFi, so to speak. Next, we have lending and borrowing protocols such as Compound and Aave. They allow users to lend and borrow assets without a centralized intermediary. And the way that these work is that once you borrow an asset, you can take it out, not on leverage, but if a token goes below a certain threshold, then your assets will ultimately be absorbed into the underlying protocol. And if it doesn't, then you get to hold on to your leverage position or your borrowed assets. Next up, we have decentralized exchanges and yield farms. And these enable users to trade assets directly with each other without a centralized exchange. And yield farms are platforms that optimize for the best returns on asset holdings. And this brings us to our next point. What is a liquidity pool? So a liquidity pool is an essential component of the DeFi ecosystem, and they really incentivize participants by pretty much distributing rewards for anybody that wants to participate in these pools and provide liquidity for the protocol to essentially function. You will be rewarded in share tokens, essentially, otherwise known as liquidity pool tokens, or LP tokens for short. So liquidity providers often earn transaction fees and are sometimes additional tokens for providing liquidity. And let's go ahead and get into this slide here. So liquidity pools are really popular in decentralized exchanges, and they are the backbone of decentralized exchanges enabling peer-to-peer trading without intermediaries. So here are some examples here: Uniswap, SushiSwap, and then we have PancakeSwap. And as you can see here, users who provide liquidity actually receive up to 43% in returns. So let's talk a little bit about Stellar DeFi versus Soroban DeFi. So why is Soroban important and how does it make a difference when it comes to DeFi on Stellar? Well, Stellar actually had a baked-in AMM and liquidity pool functionality baked into the core in protocol version 18, which was released in November 3rd, 2021. So what does this mean? While the rest of the blockchain world was on and on, or taking off and actually using smart contracts to build dApps, we were constantly playing catch up because we only had one AMM that supported one type of swap, which was a constant product with a 0.3% fee. So always playing catch up with other networks. And now that we have Soroban smart contracts, the floodgates for innovation are open. And now is the best time to build dApps on Soroban because of all of our great resources and tools that we've developed over the last year, which actually streamline development for dApps. So this next section here, we'll get into a little bit of that. So we'll be going over how to build smart contracts for liquidity pools. And feel free to scan the QR code if you want to follow along in GitHub. But here's a simple deposit function. So it basically allows the user to deposit two different tokens, token A and B, into a liquidity pool and calculates the appropriate amount of pool shares to mint for the user. Excuse me. And here's like a simple architecture diagram here, or technical architecture doc, if you want to call it that. So you'll see at the top we have authorization. And the cool thing about the Soroban Rust SDK is that we actually have authorization capabilities built right into the smart contract libraries. This means that you don't have to import any third-party smart contracts to do things like ownership and ensure that authorization is taking place in the smart contract. So as you can see here, the first of the order of operations are we fetch the reserves, which means we're getting the amount of tokens in the smart contract, token A and token B, calculating the deposit amounts, and then transferring the token from the user over to the smart contract. After this, we simply mint them LP tokens. So as you can see here in this function, mint shares. And then after this is all done, we finally update the state by calling our setter function, put reserve A, and then put reserve B. And this is basically the same thing. Here we have swap, and here's the technical architecture for that. Again, you see authorization right here at the top, fetching the reserves. And the interesting thing about this is that at all times it must maintain a constant product invariant. So this means that every time a swap is called, users who provide liquidity will get the fees that are allotted to them. In this case, it's going to be 0.3% of swaps. All right. And then once again, we have withdrawal, or finally we have withdrawal, which is pretty much the opposite of deposit. Again, we have authorization, transferring the pool shares, fetching the balances and total shares. Then we finally calculate the withdrawal amount. We burn those pool shares once they're sent back to the liquidity pool smart contract, and then execute the withdrawal by transferring both token A and token B back to the user. After this, we call our setter function, put reserve A and B, and that will update the state for us. Now, we actually have a product called the Soroban dApps Challenge, which enables users to undertake a series of dApp development related tasks. And the way that we streamline deployment is through shell scripts. So here's an example of using the CLI in a shell script. As you can see, or maybe you can't see, but the liquidity pool and token A and token B contracts are being deployed, and then they are also being initialized. So after this sequence executes, we actually move on to another sequence where we build the TypeScript bindings, which can be used in front-end components at the very end of the script. So here we are at section 6, building the front end for liquidity pools. Now, who here has used NPM packages or node modules? All right. Now with TypeScript bindings, you have on-demand NPM packages for every contract. This means you have full type ahead docs in your editor, method comments from original contract authors, and you can use it in any UI library such as React, Vue, Svelte, or even none. And this enables you to use smart contracts or use the smart contract and build front-end components by creating objects for them. So here is an example code, or here's some example code of how we would create an object and import it into a front-end component. And as you can see here, we build it in another file where we export it as an object, and it already has the appropriate RPC URL and network that it needs to communicate with. So here's the end product here. We have an example liquidity pool, which you can also check out on the Soroban DAO challenge if you want to undertake that challenge. And here is the deposit example for the bindings. So you see here on the left side the Rust smart contract method, and then calling it from the front end, you would simply refer to that liquidity pool contract object, call the method deposit, and then pass in the arguments here. Finally, at the end, you would simply await GX sign and send, which would call our wallet freighter to pop up in the front end, and then you would then sign and approve that message. Here's the deposit screen here. And again, we have swap. Left side, we have the Rust smart contract method. And on the right side, you can see how simple it is to build a component that integrates this code by calling liquidity pool and then the method swap. So here's the window for that here. And then last but not least, we have our withdrawal method. Again, on the left, we have our Rust contract. So to, share amount, minimum A, minimum B. And again, on the right side, you see the liquidity pool object, calling the method withdraw. Simple as that to be implemented to the front end. So here's this window here. And in conclusion, DeFi is stellar, is ready for you. So if you are out there building DeFi dApps, now more than ever is the best time to start developing because of all of our awesome tools and resources available. So that wraps up my spiel. Thank you for watching. And speaking of awesome resources and tools, we have a premier smart contract playground, Okashi, and I'll let him do the honors and introduce himself. Thank you.